Hello, it's James from XRobots.co.uk. This is part 7 of Robot X, the reconfigurable sci-fi walking robot. The aim of this project is to build a walking robot, which we've got quite a way with. We had some good results last time. It actually balances on 2 legs using 3 inertial measurement units and adjusting the motor speeds and positions 100 times a second. Albeit going backwards, it's a bit unstable, but the basic principle of balance is there, and it also balances if you push it around, so it's pretty stable and reacts and absorbs the load as we go, so we've got all that stuff configured. This time we just need to redistribute the mass and then we can get it to work. And hopefully after that we can dress it up as different sci-fi characters. The first one will be Bender from Futurama, and then we'll see where it takes us. So let's get right on with the build. At the top here we've got 4 kilograms, we've got 4 1 kilogram weights, 2 on each side, and it uses that for stability by trying to keep the mass still and push the robot hips the other way as it stabilises, and that seems to work pretty well as you just saw. So I think the problem is that this mass, or some mass, is too far back on the robot, so obviously it goes in the place you push it to try and absorb the load, which means if there's mass at the back when it takes one leg off the ground, it's like wearing a really heavy backpack and then basically it pulling you backwards. So we're going to try and reposition some of this mass and maybe put more on and move it forwards, but I'd like to make that adjustable so I can tune it up. So I'm just going to modify these side plates here, so we've got a flat on them and a hole through, and the round thing here is a bit more chunky, so I can drill a hole in that shaft and put a bolt through. And then I've got this piece here which is kind of like a double crank, and I can put a bit more tubing in the bottom, and these both tighten up. So that means that this will swing, of course, backwards and forwards, and I can put the weights on the end. So we're going to need to cut the poles about a bit, but that shouldn't be too much trouble. And I'm just going to print these in ABS in a fairly high density infill, so they're nice and flexible and they should be strong enough to grip the shaft. Here's one of my ABS parts, which seems to be going pretty well. So there's one of those things, about halfway up, still got quite a way to go yet. So here they're all fitted. Obviously these have clamped the shaft pretty well, and it's screwed through with this bolt here. So I've put the weights forward as far as they go on each side, so quite a bit further forward. Let's see what effect that has. Well, that had some effect. It's not as bad as it was, but it still ultimately goes backwards, so it's not really a solution. And I think the problem might be this upper body stability. So if we just turn this on again, I give it a shove, you should be able to see the body pivoting backwards and forwards here around this pivot point using this actuator I put on last time. However, the body is trying to stay stable, but it doesn't actually know what the legs are doing. So I think what I need to do is sync up that motion to make sure it actually jerks forwards when it takes a step forwards to kind of fold the robot in half, so it's pulling itself forward. So I need to do some coding around that. It may be that the trailing leg needs to be pushed back slightly as well. And at the moment it's just trying to balance, and obviously we've got this motion, so the whole robot moves, including its legs, when it goes backwards and forwards. So this is ultimately causing it to fall backwards as it takes its leg off the ground. Hey. So 4 lines of code seems to have fixed the core issue. Basically, when it goes to lift its leg forward in each side, it adds 1.5 degrees to the PID controller that does the overall front to back stability. And if you remember from last time, that deals with both the body pivot and actually influencing the legs to absorb some of the load. So you can see the legs now wobble quite a bit, which is a result of that. I need to tune that PID controller down so it's not so aggressive, but essentially it doesn't go backwards anymore, so it's actually pulling itself forward. So at least it stands on the spots, and that looks pretty good. There's a few other issues to resolve before I can actually make this walk along. So one of the things I've been talking about for a while is power regulation. So I've got little meters here that measure my batteries. It's got one for each leg, and as those goes flat it performs slightly differently. So I've added a little knob now that I can turn, and that turns up the maximum motor speed in code. So I'm actually using the motor drivers to regulate the power rather than regulating the power before it gets to the system. And those motor drivers live in the back here. There's 8 of them and a 9th one for the back to forward axis motor. And those are capable of handling 40 or so amps anyway, so it made sense to effectively use those to regulate power rather than regulate it before it gets to those. Ideally, I'd just monitor the battery voltage and set that value automatically depending on how flat the battery is, but of course the battery voltage fluctuates depending on how many motors are running, and you see these little displays going up and down a little bit, so that probably caused me some other weird oscillations unless I basically averaged that over time or had another PID controller driving it. So for now I'm just going to put up with turning the knob up a little bit as the battery goes flat. So I tried to tune out that leg wobble. It's there a little bit, but it's much better than it was. The one thing you will notice is the body is leaning wildly side to side. So I really need to try and stop that. It's actually really hard to walk by leaning like this as you take steps, and if you try it, you'll find that you actually overbalance really easily. However, the robot's actually doing the right thing, so it's programmed at the moment to stabilise side to side by absorbing load on the leg that it goes into, so it doesn't oscillate, and also by moving this way to put itself back on balance. So basically what a human would do, and that's why it's leaning out so much as it comes off balance. If you go like this and then try to do this, you just end up carry on falling. So basically I can set the set point in motion of that PID controller that deals with side to side stability. At the moment it's trying to stay as upright as possible, but it is pushing outwards to try and stay stable in the direction that it's moving so that it can rebalance. So what I need to do is set that set point so it's maybe a couple of degrees leaning in to start with, and then it can push upright and its body doesn't flail out as much. Well, I almost had that working, but unfortunately one of the actual motors is now broken. So actually the plastic gearbox is broken, the plastic tabs that were holding it in there have both completely snapped off, and also the motor is snapped. So I don't know if you can just see, this motor's now at a crooked angle because the screw holdings holding the metal motor to the plastic gearbox have broken. Trying to get a good shot of that, but yeah, that's gearbox is completely broken there. You can see that motor's not even straight. So these motors are of course drill motors, which are from cheap cordless drills with just lead screws put in the chucks, and the entire mechanism was never very satisfactory. So if I actually, now I've got it lying down, I can show you how much play there is in these motors. So accuracy and repeatability is practically impossible, just due to the fact that they're really loose, and if you imagine how much play there is at the hips there, there's exactly the same at the ankle, so it's impossible in fact to make it balance statically even. I can't position the joints to make it stand on one leg anymore. So I'm pretty surprised I got as far as I did with it and actually managed to make it go along, albeit backwards. And a lot of the things I built in terms of compensation were to compensate for those wobbly actuators, so if they were more rigid it would make it much more repeatable and much easier to configure. So I think I need to swap those out, and that was the whole aim of this project, was that we built it out 2020 extrusion, so bits could be bolted on, swapped out, new 3D printed parts could be added, and ultimately we started with those actuators knowing they weren't very good to see how it went before I go and spend some money on something decent. So I need to swap those out. I'm not sure whether I'm going to buy something off the shelf or make something out of 3D prints with linear guides with those lead screws or ball screws, but I need to take some time out to think about that. So in the meantime, we're going to get on and make Bender's body. So this is the character for anyone who doesn't know who Bender is. It's from a series called Futurama, which is a cartoon series. It's a bit like The Simpsons, but in the future, sort of. He's a fairly simplistic shape, and he gets drunk a lot. So basically, I'm going to obviously build this body that goes over. We're going to have to compromise on the legs slightly there. I'd like to make the arms like tentacles that can move around so they can bend in any direction, and there's some facial features to animate as well, but the whole body shape there to slot over Robot X is fairly simplistic. Right, I've just drawn on top of the original CAD there, Bender's body basically to the proportions I think, and he comes out about 5'3" or 4" or so. I can't make him much skinnier or the taper bring in much more because his legs of course have to move underneath, so his bottom's going to be open so the legs can work, and hopefully the whole thing will just slot on over the top. So basically we need to work on building a frame. Some of this is going to be foam over a 3D printed frame, and some of the features will be 3D printed. So I've exported that and moved it into Fusion 360, so now we've got the whole thing here. It's shelled out mostly, and I've started to deconstruct it to put the frame together. So there's basically what I'm going to print. I need to make joints and things to put all this together. Obviously that's his front door, which will eventually be another piece. So I decided I should put these hubs on the joints here, which help me hold that cross piece, so we can cut it up into pieces and still keep all of it square. So we've got one at the bottom, one in the middle and one at the top there. And then we need to continue to cut up all of these because this is quite big. The biggest part is 1/2 metre in diameter, so obviously that won't fit on the 3D printer bed. So these are mostly the unique parts. I've started cutting it up at the bottom. Each quarter is the same in fact. We've got these 2 sticks. And the hubs, and I still need to slice up the top, but we can get on with printing it and putting it together. Well, there are many, many, many parts to print. Right, we can get some of this assembled. Right, starting to piece some of the pieces together for these rings. This one is the bottom ring, this is the middle ring. I've got most of the uprights done. Still got a few hubs to come, and then we've got the top ring to do. Most of these have got a screw in, some of them are being clamped. They're all solvent welded, so this is all ABS, so we're using acetone to make all the joints. Right, we're getting there with this frame. I've made a couple of errors and put one piece together wrong, so now my uprights don't align, so I just need to put another hub here for that upright. But apart from that, everything's fine, so these will be made redundant, but it's fine because they're on the inside of the skins anyway. Right, here's Bender's upper body and shoulders, so his head goes on there, so we've got a couple of extra struts to put in when I've taken the other clamps off, but altogether that's looking pretty good, so that needs mounting on the lower body. Right, the last few pieces being stuck on there, so it's taken the best part of just over about a day and a half to print and put all these pieces together across 3 to 4 printers. Right, it's the next day, all of the acetone welds are set up and the lobster pot is complete. I had screws in while the solvent welds were setting up, so I'm going to take all of those out so they don't make lumps in my skins. So all of these hubs were rounded off so they match the contour. So that means I can wrap it up and it should make a perfect cone. It's hard to see right now, but there is actually a massive hole in the front here where the front door goes. So there's some uprights missing and things, so obviously Bender's front door needs to open. That's going to be cut out of the skins, but it seems to be a different shape depending on, well, different episodes of the cartoon and different pictures. So sometimes it's quite tapered and sometimes it's straight, so I need to decide on a compromise for that by the time I put the skins on. Right, so it should just fit over there. We need to sort out those fuse holders so they're not in the way. There'll be some mounting that mounts this to the hips of the robot. So get that just at the right height, which I think is just covering the legs at the top, and hopefully there's space for the legs to move. It looked like there were. Can go up or down a bit. So that should be about the size of it. Obviously Bender's head is pretty big, it's almost half as big as his body, but I think that's pretty much the right proportions. We can't do much about making the legs skinnier. The actuators I replace will be slightly more refined hopefully, but that's about the scale of it. Now I need to make a mounting to hold this in the right place. Now remember, the top of the body here pivots backwards and forwards about this point, but the hips here stay stationary, so I think what's going to happen is a vertical piece of 2020 extrusion that I can slide around on here, and then make a clamp to attach that to this, and that'll also be where Bender's arms attach, so that'll give it a nice anchor there so it doesn't flex the frame too much. Alright, so I've 3D printed some little brackets that go on here, so I can put this vertical piece of 2020 in, so that bolts on. There's some more holes. Now I can make something that fits to that and fits to that body frame, so that basically this can slide sideways on the 2020, and whatever fits to this can go up and down, so then I can perfectly position the body, and hopefully it's something that lifts on and off, so it's easy to get Bender's body on and off. Right, I decided never mind about it dropping on, it's just going to bolt on so it's not wobbly, so I've solvent welded these parts onto the frame and they bolt onto that 2020 extrusion. Yep, I think that should be okay. So that bracket's bolted on there and down below, and it can slide up and down on this 2020, which could of course be longer, but I think the body's high enough, and it can move backwards and forwards on the other brackets I made. So as I mentioned, yes, it will have skins. It isn't going to be a cutaway droid like the other ones, much as I like them. The plan is we can take the top off if we want to see what's inside, so that gives me the double whammy of a cutaway droid and a cosmetically finished robot. So it's going to have some sort of sheen material I think, foam wrapped around this. Obviously, I could 3D print it, but there's a lot of 3D printing, so I'm going to use sheet material over this frame. So it is going to be properly cosmetically finished. The head, however, I think I'm going to try and 3D print all of it, so let's have a look at that. So here we are. We need to do Bender's head, which I'm going to try and print, and I'm splitting it all up here so there's no support material needed. Obviously, these pieces will be the other way around there, so they're flat on the bed, and all we end up with is the what then becomes the top upside down. So this is a massive thing though. If we measure this in diameter, it's 250mm, which is about 10 inches in diameter there. So it's a huge thing. It only just fits on the print bed of the Taz, and obviously it'll be a massively long print. You know, it's a huge head there in proportion to Bender's body, considering the size of that frame that I just made. So we're going to split this up. I've got the first part in Cura here, which is the very base. And you'll notice, if we look closely at this, the extrusions are quite thick here, and that's for a reason. So you may remember I unboxed the Lulzbot Moore extruder a while ago, and this seems like an ideal job for that extruder, which has a 1.2mm nozzle and can build up the parts roughly 5 times quicker than the normal 0.5mm nozzle, and you'll still notice it's estimating nearly 4 hours here. Not sure about that, but we're going to give it a go and see how it comes out. Well, here it goes. So we're doing 0.6mm layer lines. We've got the inside and outside shell is 1.2mm thick, so that's a single extrusion with a 20% infill. So there it goes again, doing, looks like the outside perimeter, which it should go around once on the inside and the outside, then just do the infill. We're already 57 minutes into the print and about 16% of the way through, but it's still much quicker than if I'd done that with a nozzle less than half the size and less than half the layer height. We'd already be 4 hours into it or so. So we're on 2 hours 45 and we're getting a fair way along there. We're over 2/3 of the way there, so should start putting the bottom of Bender's mouth on soon. Right, that is the bottom of Bender's mouth appearing just there. So you can see there's a few defects in this, but we're probably going to have to sand it all down and fill in the gaps anyway. Right, here it is. So it took just over 3 hours, which was about what was estimated. I think it's about 200 grams, so I'm not sure how much we're going to get printed in this episode before I run out of filament. And the majority of it's come out pretty nicely, so almost could have got away without sanding that. 0.6mm layer lines, and it was printed in PLA, so it hasn't warped at all. Don't think I would have got away with that in ABS. I haven't done much PLA printing for a while. The only thing, as I did point out, was the nasty seam line, because it's a single wall, so somewhere it has to stop and start again. Unfortunately, there is a bit of a mess there, but we're going to probably sand this and fill it anyway to give it consistent paint colour with the rest of the body shells. And that goes just on there, so that's the bottom of Bender's mouth, and now we need to keep printing the other sections and stack the whole head up. Right, that's the majority of it. What we need to do next is the dome on top of the head, but that needs some support material inside, and unfortunately I've done about 3/4 of a spool of filament just for these 4 pieces, so I don't have any more filament to do any more this week. Obviously we've got the eyepiece that fits in there, which has got some thickness to it, so even though this looks like a big gap, the actual eyepiece will be thinner by at least 10 to 15mm all the way round, so that's the main structure of the head, but as you can see, it's rivaling the height of me. So the plan is we're going to have an eyepiece here with animatronic eyes in that can look all around, and the eyelids can move and it can bend its eyelids to do different expressions. The mouth I'm going to make by having a clear screen on the outside with the vertical teeth drawn on, and a barrel that rotates on the inside with kind of 2 wavy lines on it. So depending on where it turns, it can do different mouth expressions. Obviously the outside plastic won't move, but the teeth shape will move, which is basically how Bender talks. So what we're going to do with the series is take this in 2 different directions. So we're going to fork the series off. We're going to have one series for building Bender's cosmetics and animatronics, and the other series is going to be the continuation with the walking robot part with Robot X. So the next video on this will actually be building Bender the Real Robot Part 1, and we'll be putting the skins on and sorting out the head and so on. So basically there's probably going to be a break in the actual mechanics and electronics of Robot X, because I need to sort out those actuators, I need to look at some things and probably buy some stuff and wait for it to arrive. So in the meantime we'll get on with building Bender, and if you've got any suggestions for other characters, let me know in the comments below. That's all for this time. Don't forget to subscribe for more updates on this project and other projects. You should also check out my Patreon campaign, which is how most of these projects are funded. Have a look at patreon.com/XRobots and you can get access to some exclusive rewards, including a live broadcast with me and all my videos early. I also have a t-shirt store. Have a look at the links in the description. There's an exclusive design that expires at the end of March 2017. Alright, that's all for now.